process of Kalyan Chakravarti. Let's come first is outline. Today we discuss about introductions, read-off modulations and types. In types we talk about analog modulation and digital modulation. In analog modulation we talk about amplitude modulation, frequency modulation and phase modulation. In amplitude modulation we vary according to the amplitude variation. In frequency modulation according to the variation of frequency, and phase modulation according to the variation of phase. Digital modulation has three types: ASK, PSK, FSK. ASK is amplitude shift key, PSK is phase shift key, and FSK is frequency shift key. Introduction. The first thing is modulation is a combination of carrier signals and message signals. Modulation is changing of one or more of the characteristic of a signals based on the value of another signals. Means we change the value of carrier signals based on our requirement. We can change the carrier signal amplitude, we can change the carrier signal frequency, we can change the carrier signal phase. According to this, we can mix the signals and we can say this is a frequency modulation, this is amplitude modulation, this is phase modulation. A carrier is a sinusoidal of high frequency with one of its parameters is varied in proportion to the message signal. The parameters are amplitude, phase and frequency. First point is why we need. First is size of antenna. The size of antenna we calculate lambda equals to CYF. Means the size of antenna is inversely proportional to the frequency. If we take our normal strength of signals like 20 kilohertz, the size of antenna should be for transmitting that signal is 5 km. I think it is impossible to make a 5 km antenna for transmitting the signal from sender to receiver. So that's why we use modulation. By using modulation, we increase the size of message signal. Like 20 kilohertz, we can change in mega and gigahertz. That's why the length of antenna is decreased. It will come in 150 millimeters. Second thing is signal separation. Signal separations, it is a very easy to understand signal separation. Signal separation, we just take an example of our normal FM signals, FM radio mirchi signals. Radio mirchi like 98.3, 92.5, 93.5. All are different scanner. Have their scanner identity. But the basic signal, the message signal is same for everyone. Just every radio station mix their different carrier signals. Like 92.35, it will mix 90 kilohertz like, and 98.3 it will mix 96 kilohertz carrier signal. Message signal is same 2.5 to 2. Only just we mix different carrier signals, so that's why it is very easy to communicate. Third is help to recover signals. Help to recover signals means that based on the mixed carrier signal, we can find which one is message signals, which one is this signals. So according to this, we can recover our base signals. And fourth point is increase the strength. Let's talk about types. First is analog modulation. In analog modulation, there are three types: amplitude modulation, phase modulation, and frequency modulation. In amplitude modulation, we vary the amplitude of a carrier signal based on the information signal as done for radio channel, and that are transmitted in AM radio band. As I already told, how we can change the radio signals. In phase modulation, varying the phase of the carrier based on the information signals. And frequency modulation, varying the frequency of a carrier based on the information signal done for channel transmitted in FM bands. In FM band. In frequency, all three have same things. In amplitude signal, we change the amplitude of carrier signal. In phase modulation, we change the phase. In frequency, we vary frequency. So first is amplitude modulation. AM work by varying the strength of amplitude of a carrier proportional to the waveform being sent. That waveform may be, for instance, correspond to the sound to be reproduced by a loudspeaker or a light intensity of television pixel. So this is the basic figure of this amplitude modulation. There are three, in here I take total three types of modulations, three different example of modulation. First is 50% modulation, second is 100% modulation, third is 150 modulation. In 50% modulation, the signal is just live only just between 0.5 to 1.5, and 100% modulation, it is start from base means zero line and end is zero line. And similarly for 150 modulation, it is start from 0.5 and it cross the baseline, zero line to G minus 0.5. So this is the idea. The red dot are the representation of message signals, and the blue line are representation of carrier wave signals. So here is, we take 50% modulations. We can see this is live from 0.5 to 1.5. Similarly in negative direction, it is live minus 0.5 to 1.5. In 100% modulation, it is start from 0 and touch the baseline, 0 line. See there, it is start from basis 0 and touch the 0 line. Same things. And this is our carrier wave. And 150 modulation, it is start from 0 and it touch the baseline and also cross the baseline. This is 150 modulations. And second is frequency modulation. As I told, we varied the frequency. In telecommunication and signal processing, frequency modulation is the encoding of information in a carrier wave by varying the instantaneous frequency of a wave. So this is the simple example. These are our carrier signals, simple negative positive direction. This is our modulating sine wave signals. This is positive and this is negative direction. Whenever the negative peak will come, the frequency will increase. See, in positive direction it is normal, but whenever it will start in negative direction, the frequency of signal is start to increase, and the maximum peak frequency signal, it will their maximum frequency. See, similarly then it will also decrease the frequency till this point, and in positive direction it is normal. In negative direction everything is repeat same as I told. Third point is phase modulation. Phase modulation is a modulation pattern that input information as variation in the instantaneous phase of carrier wave signal. In phase modulation, we vary the phase of signals. The phase modulation is widely used for transmitting radio signals. Is an integral part of many digital transmission coding schemes that are applying a widely range of technology like Wi-Fi, GSM, satellite televisions. So these are, this is the simple carrier signals, and this is a modulating sine wave signals. See there, whenever the phase modulation is the final signal phase is changed. Here the phase is starting positive direction. See, from this point, carrier signal also same positive direction. But the phase modulation signal, see there, that point, it is positive direction, but now it is in negative direction. It is start from negative direction. Similarly for that point, it's going in negative direction. See there, negative direction, but it is in positive direction. So similarly, it will change their phase. This is overall normal view of analog modulation. Let's discuss about digital modulation. The digital modulation, I think today in today's world, it is a very important digital having a very important role. That's why digital modulation is very important. It is very useful to analog to digital converter as well as digital to analog converter. So there are three types of in digital modulation: amplitude shift key, frequency shift key, and phase shift key. These are all three types of different types of modulation which we are discussing in digital modulation. In digital modulation, it having many advantages over simple analog modulation and also analog communications. Digital modulation, it is very easy to recover our signal from their noise. But in these analog signals, once we lose our strength of signal, it is very tough to recover our signals. That's why we mostly prefer digital signals. So this is our basic diagram of. Let's take a simple example of digital modulation. The first is, this is positive direction, this is negative direction, and this is negative direction, this is positive direction. So first is amplitude shift key. In amplitude shift key, values represented by different amplitude of carrier. Like 0 is having presence of carrier signals, absence of carrier signals 1, and 0 is present the absence of carrier signals. Means whenever the 0 come in input, our output is carrier signal. So, but whenever the negative means 0 is coming input, the output of carrier signal is nothing. It is absence of carrier signal. So we can see in diagram, this is positive direction, the carrier signal is present, but in negative direction there is no carrier signal. It is typically it is used for 1200 bps on voice grade lines, and it is very useful in today communication, means under over optical signal. And second thing is frequency shift key. Values represented by different frequency. The main advantage, it is less susceptible to error than ASK, and typically it is used for up to 1200 bps on the voice grid line. It is a high frequency radio, even higher frequency of lane using XA. So we can see in positive, whenever the signal is 1, the carrier signal is, the frequencies remain same, but whenever the signal is 0, means the bit is 0 in negative direction, the frequency of carrier signal is very slow. You can see there, in positive direction it is normal state, but in negative direction it will come in very slow speed. In phase shift key, this is the phase of carrier signal shifted to the present data. Same is like analog modulation. In positive direction, it's okay, it's going on. Whenever the phase change, means it will come in 0 direction, it is automatically carrier signal phase change. See there, now it's changing in positive direction, the carrier signal is changed from their state. Same in negative directions, the stage change, that one will change. So first we let's discuss about sending multiple bits. In summary, each of 3 modulations technique can be refined to send more than 1 bit at a time. It is possible to send 2 bits on one wave by defining 4 different amplitude. This technique could be further refined to send 3 bits at a same time by defining 8 different amplitude level of 4 bits by defining. The same approach can be used for frequency and phase modulations. So this is the overall view of our digital modulations. There are many various factors which I want to discuss you. Various factors should be considered for choosing a particular modulation scheme to be used in communication system. A modulation scheme should be spectral efficiency, and possess low bit error (BER). It should be low error, especially at low signal to noise ratio. And modulation scheme should also perform will be in multi-path and fading environment. Cost effective, simple implementations are also a key desired features. Exciting modulation techniques do not offer all these features simultaneously. Some modulation are spectral efficiency, however their BER performance is not exceptional. Bandwidth efficiency and energy efficiency are 2 parameters used to quality the perform of modulation technique. Bandwidth or spectrum efficiency is the number of bits transmitted per second per hertz of bandwidth or data rate per hertz. Energy efficiency is the ratio of signal energy per bit to per bit to noise power spectrum density required for certain VAR of receiver. So this is the overall idea of digital modulation and this analog modulation, factor and need and different types. Thank you for listening.